Hey guys, how's it going? In this video, we're going to learn about working out the equivalent resistance of circuits, okay? The equivalent resistance between any 2 points for a resistor network, okay, like this one. So, just a few notes. We have what we call a parallel connection. So a parallel connection would be, for example, you have current flowing in this direction. Okay, this is current. And then when the current branches into two, so let's call that resistance, resistor 1, resistor 2. We say that these resistors are in parallel, okay? It simply means here you can see that this top runs with this top. And what it means in terms of the electrical aspects of it is that the resistance, the current actually branches such that some of the current goes here and some of the current goes here. Okay, it splits. It's not like all the current goes in. So here a parallel connection will be having like this. So you can actually have more and more connections. So you'd have R3 here, okay, in parallel again. So this one would be slightly different, but essentially that's what we'll be having. And would have, let's say, connection. Okay, so we'll be having a connection here. Let's say there are so many, and we'll be having, let's say, Rn here. So I'm not really good at drawing, but essentially these are all in parallel. Okay, they share the same current. This current has to branch to all these branches here, parallel branches. So what we discovered in electrical engineering is that R, which is the equivalent resistance, okay, we can say Req is equal to, for parallel connection, it's equal to, we sum all the inverses for the resistors, okay. So 1 over R3 plus dot 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 1 over Rn to the power minus 1, okay. So in other words, if you want to calculate the equivalent resistance for this, you have to first add the inverses, add the reciprocals, and say to the power minus 1. If you're really good at math, you can also say 1 over Req is equal to 1 over R1 plus 1 over R2 plus 1 over R3, like this, plus 1 over Rn. Okay, so plus dot dot dot, okay, then we say plus this, okay. So essentially so plus dot dot dot, then we say plus this, okay. So the inverse of this, so when you're calculating, I advise you to actually make use of this one here, okay. It's quite simple. And normally if you're doing combined science, what you'll be having is a situation where you have only this current, and then you'll be having one branch, so you'll be having R1 and R2. They never actually like give you more than two parallel connections, okay. So like this. So in this case, the equivalent resistance would be Req equal to, just like what we said here, we have to sum 1 over each and every one in the each and every resistor value in the parallel connection, okay. So to the power minus 1, like this. So here we can put a common denominator. We're going to work out what's in brackets first. So the common denominator would be R1, R2, like this. So here R1 into this you get R2, okay. R2 by 1 you get R2. Then R1 into this you get R1, R1 by this you get R1, like this. To the power negative 1. If it's the power negative 1, what it simply means is we can flip the fraction and get rid of the negative, okay. This is consistent with the laws of indices, okay. So R1 plus R2 like this. So we say this one, we say product divided by sum. Okay, this is only for the case of two resistors, only for two resistors in parallel. Okay, two resistors connected in parallel. If we have more than two resistors connected in parallel, we have a problem. Okay, it's slightly different, so we are supposed to use this one. If you have a double screen calculator, then you can actually punch this whole thing here. So it may be 1 over 2 plus 1 over 3. You can just put your whole brackets, then you punch, then you say to the power -1. You'll be able to compute your answer. But then for the purpose of combined signs, normally they just test for the case of two parallel connections. This is what you're supposed to remember. Okay, this one here, right here, you're supposed to remember that it's equal to product over sum. Whenever you have a parallel connection, the equivalent resistance equals to product over sum. Okay, so you can actually ignore all this. Then we have what we call a series connection. In this case, series simply means one after another. So you can have resistor 1, resistor 2, resistor 3, then you have resistor N here. All these, they receive the same current. Okay, they receive the same current because they're in series. So the current for series elements, it's always the same. So the R equivalent, which is the equivalent resistance, would be equal to R1 plus R2 plus R3 plus dot 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 Rn. Okay, it simply means you have to add all the elements that are in series. Okay, so and then sometimes what you have to keep in mind is that you can be given a planar network. A planar network has series and parallel connections. So in that case, this is what I need you to do. So the series connection, it's simple. You just simply add all the elements that are in series. And then for parallel connection, we said for the case where we have two resistors, it's simply product over sum. But then for the case where we have more than two resistors, we have to be a little bit more careful and use that other elaborate formula. Okay. So if you have a planar circuit, it might be slightly different. So I want us to use these symbols first, because we want to take the diagram to interpret it in a way that we can use mathematically. Okay, so we look at the diagram by inspection. You should be able to figure out the connection that's there. And then once you figure out, you decode mathematically, then you just apply the proper mathematical formulas in order for you to get the equivalent resistance. Okay, so you use this symbol here. So this symbol here to mean parallel connection. Okay, I'm telling you a very useful mathematical way to work it out. Plus use to mean series connection. Okay, so you can have, let's say here you have, let's say R1, here you have, let's say R2, and then these two, let's say that they are leading to R3 here. Okay, so you're asked to find the equivalent resistance between points A and B. Figure out how to present this using the symbols that we have outlined here. So for example, R1 and R2, they are in parallel. So you'd say R1, R2. Okay, it's just a notation that makes it simple, especially when you have so many resistance, so that you get off your diagram as quickly as possible. Okay, then here this is in series with this parallel connection, so we have to say plus R3 separately. You see, so this one is equal to our equivalent resistance like this. And then now for the parallel connection, remember it's equal to product over sum. So it's simply R2 R1 divided by R1 plus R2, the product divided by the sum. Then we add R3 separately like this, and then you'll be able to figure out the you'll be able to figure out the equivalent resistance. Okay, let's try this using actual examples. You see, it won't be that hard, it'd be easy. So for example, we have this, okay, and we're asked to find the equivalent resistance, let's say between A and B. So what do? First write, okay, you can say let the equivalent resistance be what? Let's say be Req, okay. So now you're going into it, so Req is equal to, let's use our symbols, okay. So here start from usually we have to start from the end, but then start at the beginning here since it's a simple circuit, okay. So you actually have 2, you can say 2.0, but for this purpose you can just say 2, it's still okay, okay. So 2 ohms, and after this 2 ohms here, it's in series with this. This section here is different, and this section is in series with this, okay, and also it's in series with the whatever external connection will be here, okay. So you say plus meaning it's in series, okay. This part now is what you have to figure out. You have 2 sections. This upper section, let's call it C, and this down section which is D. So C is in parallel with D. So how do you simplify that? You simplify that by using brackets, so that it goes hand in hand with whatever you have written here, which is external to that part of the circuit. Okay. So C is parallel to D. So C is equal to 6 ohm plus 10 ohm. This is C. Okay. This is the upper part. The upper part you're supposed to decode it as it is. So here the upper part would be adding. So we say this, and then the upper part is in parallel with 4, like this. Okay. So now you're going into the ROM. If you want, you can even not write this, and then just remember to include the sign, because my signs are very terrible. Just remember to include the sign at the end. But essentially, this part is separate. So we say 2, and then it's in series with this whole part. So this whole part is C in parallel with D. But then this C now, it's compound. You have 6 and you have 10. So you combine them. They're supposed to be adding. Why? They are in series on their own. Okay. And then this series connection is in parallel with this 4 here. So you'd have smuggled this into the realm of math. So this one is actually 16. And you have 4 here. Okay. So we say 2 plus, and then whenever we have parallel connection, we say that it's product over sum. Parallel connection of 2 entities, it's product over sum. So it'd be 16 plus 4, like this. 16 times 4 over 16 plus 4. So you'd have 2. Here you don't need to expand. You can just leave it like that. So that here when you get 20, then you can cancel out some stuff very easily. Okay, so it'd be 5. It'd be 4 into 20. You can even divide this by 2. Okay, you see the advantage in dividing by 2, so you get 10 here. Thus 2 into 4, you get 2 here. So you actually get 2 plus, here you get 32. 32 divided by 10, you get what? 3.2. So equivalent resistance is equal to what? Is equal to 5.2 ohms. Okay. So you have to figure out first, we want to smuggle this whole thing into the realm of math so that you can apply the proper formulas for you to get the equivalent resistance. So you have to analyze first, inspect what's happening. From A, you want to get to B. So here, this is a series connection. So you get 2, then you say plus, you rest. This is a parallel connection. It's made up of 2 branches, okay? This one, the C branch and the D branch. What's the C branch saying? It's saying 6 plus 4. Separately, we use brackets just because this branch is the one branch singular. And then it's in parallel, we use this symbol here. It's very convenient for us to use this symbol, this parallel symbol, okay? So just don't confuse it to 11. It's not 11, okay? It's a parallel connection here. So if it's a parallel connection, then we say with 4, right? So 16 and 4, if it's a parallel connection, we say product over sum. And once we say product over sum here, you can simplify the way that you want. You can even say 16 multiplied by 4, then you get 64, then you say 64 divided by 20. You'd still get the same answer, which is 3.2. Then you add with 2, then you get 5.2. That would be your equivalent resistance. Okay, let's quickly move to the next part, next illustration. So here we have this one is A, this one is B, and then we asked to find the equivalent resistance. What I want you to do is just pause the question. Here you have to define, let RQ be the equivalent resistance between A and B. Okay, so you have to define, and then just pause the question, just pause the video, and then try to work it out on your own. I want you to analyze here and then come up with a formula depending on which is parallel. Remember, our symbol for paralleloids, it's this, and our symbol for series, it's this. Okay, just figure it out. So here we have two sections, this section here and this section here. These two sections, they are in parallel. Okay, so this upper section here comprises stuff in series. Okay, so 3 plus 3 plus 3. You're not seeing any other connection here. They are just one after another. Well, this one is taking after this one, and this one is taking after this one. They are in series. They are just connected head, tail, head, tail. Okay, so that's why we say that they are in series. And then here, this series connection is in parallel with this one here. So here you have this. We know that they are in series because it's one after another, one after another, one after another. But we also know that these are in parallel because this upper part, it's running in parallel with this lower part. So you actually have this, so here you simplify. You're now in the realm of maths. Okay, so this one you simply get 9. So make this bigger so that someone can know that this is a parallel connection. Okay, these are not necessarily 11s, they're actually a parallel connection. And if it's like this, what do? We say product divided by the sum. Okay, so you get 27 here divided by, here you get 12. Okay, so you can even say 3 into 12, you get 4. 3 into 27, you get 9. So 4 over 9. Okay, so 4 over 9 is equal to, so if you want, you can say 4 into 4, 1 into 9, you get 2 remainder 1 into 10. Into 9, you get 2 remainder 1 into 10, you get 2 again, remainder 2 into 20, you get 5. So you get 2.25. Don't forget your sign. Okay, ohms. If this one is a little bit hard for you to write, you can even say ohms. It's still okay like this. But then essentially you have to identify via analysis, a quick analysis. You have to identify, and you have to be able to interpret whatever will be happening here mathematically. And once you interpret mathematically, then you proceed to do your calculation. Let's quickly move to the next part. The next part, we have this, and we asked to find the equivalent resistance for the whole circuit. Equivalent resistance for the whole circuit. So how do you do it? EQ again is equal to, then start from one part. Okay, if you want to start from here, it's still okay, but start from one part and then circle and then go around. This one, it's coming after this, so it's in series with us. So this is simply 5 here, and it's in series with this parallel connection. Okay, this parallel connection, now you're used to it. This upper part here, it's 8 plus 2. Plus here simply signifies that 2 and 8, they are in series. One comes after another. Okay, and this, it's in parallel with this 10 here. Okay, so you have 5 plus 10, 10. Another tip is whenever you have A and A, value A, the equivalent resistance here will be equal to what? Be equal to half A. But let me show you why that is so. If you're confused in any way, don't use what I'm trying to tell you, okay? Just use the normal method that you know. So here, for example, I would have said 10 and 10 gives 5. 10 in parallel with 10 gives 5. But if you don't understand it, then you have to do the elaborate process, product over sum. So here we get 5 plus, here would be 100, 100 divided by 20. Okay, so it'd be equal to 5 plus 100 divided by 20, you get 5. This is what I was telling you. Okay, then at the end of the day, you get 10. 10 what? Ohms. Okay, so 10 ohms. This one would be the equivalent resistance. So first of all, identify, make sure that you're able to evaluate the statement for the equivalent resistance mathematically. So you use the symbols that I've told you. It's kind of easy for you that way. And then once you use the symbols, then you complete. It will be all be math afterwards. Just remember that whenever we have this parallel connection, this parallel symbol, we say product over sum. Only that, and then you'll be fine. So let's start this one. This one, it's a bit tricky. Okay, so we have REQ equal to, so we have 2 plus, then all these they are in parallel. Okay, so it's actually 20, then we have 10, so it's 20 in parallel with 10 in parallel with another 10, like this. Okay, so we'd get 2 plus, then we say that if it's like this, we have to say 1 over each and every element. So 20 plus 1 over 10 plus 1 over 10 again. Okay, then we say over to the power negative 1. Okay, reciprocal. So here we're not saying product over sum because these are 3. When we have 2 of them, then we say product over sum. When we have 3 or more, we have to do this elaborate process here. You just say 1 over each and every resistance that you have, and then you put in brackets and say to the power negative 1. To the power negative 1 is important. If you miss that, then it's going to be a problem for you. Okay, so this is simply 2 over 20. Yeah, this is simply 2 over 20. Power minus 1. Okay, so you'd have 2 plus, here you'd get 3 or 3 over 20, right? You get 5 over 20 because you have 1 and 2 and 2. So 1 plus 2, that's 3 plus 2, that's 5. 5 over 20 to the power negative 1, like this. Then you get 2 plus, this one would be 1 quarter to the power negative 1, like this. Then it's carrying over to here. So REQ is equal to 2 plus laws of indices, flip. So this one you have to take the reciprocal. So if it's a fraction, you just flip it. So it becomes 4 over 1, which is 4. And then 2 plus 4, you get 6 ohms. Okay, did you get it? So if it were this wasn't present, then you would have said product over sum, just because you have 2 entities. Here you had 3 entities. If you have 3 entities in parallel, what you do is you say 1 over each and every entity. Then you put in brackets and say to the power minus 1. Simplify the brackets first. Okay, if you have a calculator, you can even punch this in, get it as a fraction, and afterwards you flip it. You flip it to get rid of the negative 1 here, and then you get 4, and then you just simply add. In other words, write this statement first. This statement is what's important. Once you get this statement right, everything else is just maths. If you're good at maths, then you'll be able to ace your equivalent resistance. Okay, let's see if we have, I think we have 2 more. So this one, how do we go about it? I think this one we have covered it already. So we've covered it already, and yeah, so sometimes you're given statements. Okay, so you have to know again, how do you calculate? Okay, so let's say question 5 here. So you're given 3 resistance of values 3, 6, and 12. They are connected in series. Okay, what's the equivalent resistance of the combination? You are told that they are connected in what? In series. If they are connected in series, we say that we simply add. So it's 3 plus 6 plus what? Plus 12. So 3 plus 6, that's 9, plus 12, you get 21. 21 what? Ohms. Done. If you want to write it as 21 ohms like this, it's still fine. Okay. So sometimes you're given these as statements, so you have to know again how do you evaluate. So 3 resistors are given for this and this, they're connected in parallel. What's the equivalent resistance? This time they're connected in parallel, so you're dealing with the case of this is 4 ohm and this is 6 ohm and this is 10 ohm. If it makes sense for you to draw the diagram first, then just do. Okay, these are in parallel, and we say that if they're in parallel and there are more than 2 of them, what do? Put your big bracket, say 1 over the first one, plus 1 over the second one, plus 1 over the third one. Okay, like this to the power -1. Here, what you do, you can actually just calculate to say 1/4 plus 1/6 plus, or if you want to get the exact answer, you can put the common denominator here. So it'd be, for our case, it'd be, okay, it'd be 60, since we have 4 here. So the lowest common multiple would be 60. So the lowest common multiple would be 60, and then you'd be having 15 here, I think. So you'd be having 15 here. 4 into 60, you get 15. By 1, you get 50. You get 15. Okay. 6 into this, you get 10 here. Then here you get 6 here. Then to the power -1. Okay. So you actually get this one would be 21. 21 plus 10, you get 31. So you get 31 over 60 to the power -1. Then you get 60 over 31. So 60 over 31 is approximately what? Punch on your calculator and then see if I'm also going to do the same. So 60 divided by 31, you get 1.9 approximately, okay? In some other countries, they don't write their comma like this, they just write their commas like this. But then for ZIMSEC, you have to write your commas in this way, okay? And this symbol here, it means approximately. So it means that you're rounding up. And then we got 1.9, just like what we said. So here, if you wanted, you could have drawn the diagram, which would have been okay. So 7, let's see, 2 resistors with values this and this are connected in parallel. Now you're given, it says 2 resistors, so the 6 ohm resistor and the 12 ohm resistor, they are connected in parallel, okay? The combination is then connected in series with the 4 ohm resistor, okay? So now you're asked, what's the total equivalent resistance? So it'd be Req equal to, so here we say parallel connection, we have to use this symbol here, okay? If you make it long, then that's, if you make these lines long, these bars long, then it shows clearly that these are not ones, they're actually symbols. So plus 4 here. So here would be product over sum. The reason we are saying product over sum is because we only have 2 entries, okay? So 6 plus 12 here plus 4. So here would be 6 times 12 over 18 here plus 4, like this. So here would be 6 into 6, 1 into 18, you get 3. 3 into 3, 1 into 12, you get 4. Then 4 plus 4, you simply get 8 ohms, or 8 ohms, like this. Okay, so these are your answers. So that's it. So just to recap, we talked about parallel connections, and we said parallel connections, it's somewhat easy to use this, and then this symbol here, and then for series connections, it's somewhat easy to use this symbol here. And parallel connections, it means that they'll be sharing a node, so it would be like this. They are sharing one point here. You are dealing with branches, okay? So this one would be the parallel connections. So they have 2 points that they are sharing here. That's what makes them parallel connections. And then for series connections, parallel. For series connections, we simply say that they are sharing 1 point, okay? It's one coming after another. So we have R1, R2 here in series. It means that they're sharing a point, one coming after another. And then for parallel connection, we say that R equivalent is equal to, we say 1 over R1. You are just taking all the entries, R3 plus dot 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 1 over Rn, and then we say to the power -1. Okay, then we say that we simplify the brackets first, and then we check the inverse. We flip our number, and then that's how we get the equivalent resistance. And then we had a special case for Req, and then that special case was for when we have only two resistors in parallel, and then we say that it would be R1 times R2, so which is the product over the sum R1 plus R2. Okay, this is what we said. And for series connection, we simply add, so R1 plus R2 plus R3, depending on what resistors we have. Okay, so this is it. If you're studying your combined science, then you have a jump start now. These are stuff that you can score very, very easily on, especially if you're good with math. Okay, and then I advise you now that if you want to, because sometimes you learn, but then you actually don't grasp the concepts. Learning from someone who is doing it and you doing it yourself, they're somewhat different. Okay, that's why sometimes you see you study, but then you actually get, maybe you fail or you don't get marks that you were expecting, just because when you're seeing someone doing it, it feels easy, but then you have to do it yourself. So I want you to go to the start of this video, and then you go to each and every question, you do it on your own. Okay, and then you compare it with the answer. You compare it with the solution that I have put there, and then you move to the next, you move to the next, and then you do those three. If you have done this, I promise you that whatever question will come on a series parallel resistors, you'll be able to answer real easily and real quickly. Okay, so make sure you like, share, and subscribe, obviously, and I'll catch you in the next video. You out.